All right, 7.2 is about parallelograms. So the point of this section is to prove and use theorems about the properties of parallelograms and prove and use theorems about the diagonals of parallelograms. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So from B to C, it's parallel to A to D, and then A to B is parallel to D to C. So in order, when you're looking at any kind of math terms, if you see this symbol, it means that it is a parallelogram. So some of the theorems for properties of parallelogram. 7.3 says if a quadrilateral is a parallelogram, then its opposite sides are congruent. Theorem 7.4 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. 7.5 says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And if you remember, supplementary means equals 180. And 7.6 says if a parallelogram has one right angle, then it has four right angles. So let's look at this one. So it says use properties of parallelograms. So our goal is to find what CD equals. And it's told us that CD is equal to AB. So opposite sides of a parallelogram are congruent. So if AB is 4 feet, what do you think this side is? So the definition of congruent, so we're just going to fill this in now. So CD, and it's just the same thing as what's above, just without those lines above them. So CD is equal to AB, and since A to B equals 4 feet, CD also equals 4 feet. That's it. So let's try this one. So find each measure. So we want to know what angle D equals, and we want to find out which one is congruent to that. So if we're looking, we go back to these theorems, it tells us that right here in 7.4, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if I'm looking at D, opposite of that is 106 degrees. So I know that it equals 106. So now I'm going to look at F to G. So from F to G, I know that going back to my theorems, the opposite sides, 7.3 tells me that opposite sides are congruent. So if D to E is 8, G to F also has to be 8. So in this case, my answer would be 8. All right, so the next part is proofs using the properties of parallelograms. So write the correct statements and reasons to complete the 2-column proof. So the symbol parallelogram HJQP and parallelogram PKLM. So they want us to prove that line H to G is equal, congruent to M to L. So here's what they've given us. And we know that whenever we fill in any kind of proof, our first one is always given. So that's my number 1. So I'm going to look at my first, now my second one. So if I look at HJ is equal to PK, and PK is equal to LM. So that's going back to my theorem, and it tells me that the opposite sides of a parallelogram are congruent. So we're just going to write opposite sides are congruent. And then if I look at my last one, so HJ is equal to LM. That one is transitive property, and if you just remember, transitive property just means that they are equal, that they are the same, that we could flip it. Okay? So let's look at next. So now let's try this one. So write the correct statements and reasons to complete the 2-column proof. So parallelogram JKLM and k to n is equal to k to l. So they want us to prove that j is equal to k, n, and l. So we're going to start with what they gave us. So my first part is given. So now they've given me the reason, and we have to fill in for the statement. So if the quadrilateral is a parallelogram, its opposite angles are congruent. So what would be an opposite angle that would be congruent? So if I look at J, the opposite angle to J is L. So that one would be what would go there. So we're just going to write J equals L. And then isosceles triangle theorem tells me what we're trying to prove. So in the next box where the statement is would be what they gave me right up there. So J equals KNL, because this part over here is a triangle and it would be equal to that. And then the last part is, so the same thing now, angle J is equal to KNL, and that one is again my transitive property, just telling me that they equal one another. So the next part, diagonals of parallelograms. So the diagonals of parallelograms have special properties. So those two theorems tell me that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So remember, bisect means that it cuts it in two, and then they're equal. And theorem 7.8 tells me if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So when I cut that diagonal from one point to another, it would make two triangles. So use properties of parallelograms in algebra. So find the values of x and z in the parallelogram A, B, C, D. So this whole parallelogram. So they're telling me that from A, D, C, it equals 4x. And then they're telling me from D, A, B, it equals 2x minus 6. So I know that my parallelogram equals 180 degrees, so I'm going to start with finding my x. So I know that those two angles, consecutive one after another, are supplementary, so that's why I would equal 180. So now I'm going to plug in what they gave me. So they gave me up at top the ADC equals 4x plus, and I'm plugging in for my DAB, which they gave me, is 2x minus 6. So now I would combine my like terms, and I'm just going to do that right over here. I'm going to do it right above it. So now I have 180 degrees equals 6x minus 6. So the first thing I'm going to do is subtract 6 from both sides. Add 6 to both sides. I have to do the inverse. So now I have 186 equals 6x. Then I'm going to divide by 6. So I'm going to do 186 divided by 6, and it gives me 31. So x equals 31. And now I'm going to solve for z over here. So my AE is equal to CE. So these are equal. And that tells me that my diagonals bisect each other, so my sides are going to be equal. So AE is equal to CE tells me that's the definition of congruent. So 3z minus 4 is going to equal my other side, which will be my z plus 5. And then I'm going to do this right up here. So if I have 3z minus 4 equals z plus 5, I'm going to add 4 to both sides. So now I have 3z equals z plus 9. Then I'm going to subtract my 9, or my 1z from both sides. So now, now I have, so 3z minus 1z gives me 2z equals 9. And I'm going to divide by 2, so my z gives me 4.5. So z equals 4.5. All right, go ahead. You can make your lesson. If you have any questions, ask me. And here we go.